Let's take a look at our first section in chapter 2, which is 2.1. And the big thing we're going to learn in this section is how you can change between different units of measuring an angle. Okay, there's two main units we use. Degrees is one, radians is the other. Okay, so I'll show you how to change between the two. There's a few things we'll have to take a look at first. Okay, so as we go through the lesson, that's the big question we need to answer. Okay, we know that in one revolution, that's 360 degrees. But the question is, how many radians is that? Okay. Knowing that right there would allow you to convert between revolutions and degrees very simply. Okay? If I know in one revolution there's 360 degrees, I could say to you, how many degrees in 2.5 revolutions? All you have to do is set up a proportion. So if in one revolution there's 360 degrees, 2.5 revolutions, how many degrees? And we could solve it. Okay, we're not going to solve it, but you could. Okay. Just knowing this fact on the left, can I convert between any number of revolutions and any number of degrees I want, or can this only do certain conversions? What do you think? Well, Jared, what do you think? If I know that there's 360 degrees in a revolution, can I convert any number of revolutions I want to degrees? Could I do 2.6 if I wanted, or 3.9? Yeah, I can do anything. Okay? So just knowing this one fact allows me to convert anything I want between degrees and revolutions. So if I can figure out that fact, how many degrees equals how many radians, I can convert between any number of degrees and any number of radians. I just need to know that one fact to start with, and I can do anything I need to. All right, so before we get into really talking a lot about angles, I just want you to keep this in mind, okay, this fact for the whole lesson. Okay, how many radians equals how many degrees? We're going to talk about something even simpler in just what's an angle. Okay. If you already have the title, you don't need to write the title twice. It's the same title. Okay, so basically, angles are made up of two sides. Okay, and we call those sides rays. Okay, a ray is a portion of a line. It has a starting point called a vertex, and it continues in one direction forever. Okay, now if we take two rays and put them together, okay, with a common vertex, okay, a common starting point, that's when we create an angle. Okay, so here's an example of an angle. Just take two rays, give them a common starting point, common vertex, we just created that angle. Okay, when you create an angle, it has two different sides. Okay, one of the sides is called the initial, and the other one is called the terminal. Does anybody know in this angle which one is which? Okay, so the way you tell is you rotate counterclockwise inside the angle, like this. from there to there. The side that you start at, that's your initial side. The side that you end up at, that is your terminal side. Okay, so you always rotate inside the angle counterclockwise. Okay, and that direction that we rotated also has something to do with the kind of number we get when we measure an angle. Anytime that you rotate counterclockwise, you are measuring a positive angle. Okay, if you rotate clockwise, you're measuring a negative angle. Okay, and I'm going to show you that in a second with a little interactive thing I can bring up on the board. Okay, so I'll bring this right back up in a second if you still need to copy. Let me. Okay, so what I'm going to bring up from my computer is this. So basically, this is a unit circle, okay, which I might mention this term a little bit later today, and we're going to spend a little bit of time studying it next week. I can't move the initial side. I can only move the terminal side of this angle. And notice as I start to move it counterclockwise, okay, it's measuring a positive angle. Okay, that's 195 degrees. As I start to go back the other way, now I'm measuring a negative angle. Okay, so that's the only difference whether you measure, if you measure clockwise or counterclockwise, you're either talking about a positive or a negative. Okay, and that shows us that there might be different names for the same spot on this chart. Okay, negative 90 and 270 both land right here. They're really the exact same thing. The only difference is which way did you go to get here, clockwise or counterclockwise. Okay, so we'll talk more about that too in the future. Okay, so any questions on the difference between rotating clockwise or counterclockwise when you measure an angle? All right. Okay, the next thing is, how do we draw an angle? Okay, there's lots of different ways you can do it. Sometimes we might draw it like they were in the diagram I just showed you. Okay, I like the way this one is drawn. Right here, that one's nice. Bless you. Okay, that one, not so much. Okay, there's something I don't like about this angle. So there's a way we can draw angles. That's the standard way, and that's called standard position. And two things have to happen for an angle to be in standard position. First thing that has to happen is when you draw it, your vertex is at the origin. Second thing is that the initial side is on the positive x-axis. Okay, so vertex at the origin, initial side on the positive x-axis. So if I ask you to sketch an angle in standard position, that's what it means to do. And down below what I have here, this angle in red, that's a diagram of an angle in standard position. Okay, what if I took this angle and went like that? is that still standard position? No? How come? Right, the vertex isn't at the origin. The initial side is still on the positive x-axis, but I have to have that vertex at the origin. Okay, what if I went like this? Put it like that. Is that standard position? Nope. How come, Connor?
It's not on the positive x-axis.
Right. The terminal side is on the positive y-axis, but that's not part of the definition at all. It's the initial side. It's got to be on the positive x-axis. Okay, so that's standard position. Okay, so that's kind of the background I wanted to just give you on angles. Okay, how they're made up of two rays, how we draw them, and the different directions we can measure them in, meaning either positive or negative angles. Any questions on that? Right, so now for the rest of the time, we're going to try to figure out the answer to that question that I gave you guys at the beginning. How many radians in 360 degrees? Does anybody know, either from shop or from another class? Some of you might know. Should know. Some people know it as a decimal. We generally are going to write it in terms of pi. And I don't know if, did anybody notice, this was the last angle I come up on the screen. Did anyone notice this 3 pi over 2 before I just pointed it out to you?
Yeah.
Okay, that has something to do with radians. And you might notice that sometime it changes to a decimal, and then depending on the angle, it might change to having the pi symbol in it. Okay, so there are certain 180. 180 goes in the bottom, which means what has to go in the top? Pi. To 60 and 180. 3? Yeah, can you go even bigger? I think really big. 30, even one more bigger. Not that big. Too big. You want to help her out? Yeah? 60. If you don't find the biggest number right away, that's okay. You're going to have to reduce a couple times. Okay. Katrina, how many times does 60 go into 60?
I mean, what?
You can answer my next question. How many times does 60 go into 60?
Once.
And how about into 180?
3 times.
There's the 3. Okay, so just multiply straight across. 1 times pi. 1 times 3. There's your answer. Pi over 3. Okay, and maybe you noticed when I went to 60 degrees on this diagram, all of a sudden it changes from a decimal to pi over 3. Okay, so 60 is one of those angles we usually don't write as a decimal. We leave it as pi over 3. In fact, any angle that's a multiple of 30 or 45, we will always write it as a fraction like that. So 30, 60, 90, 120. Okay, all your multiples of 30 and all your multiples of 45. Okay, the other thing we have to kind of get used to is the book is not going to write RAD. Okay? They'll always put the degree symbol if they mean degrees. You have to. But if you're ever talking about an angle and it's in radians, they usually leave the RAD off. Okay? So from now on, I want to try to get used to it without writing RAD. All right, so how about Paige? I'm going to convert 150 degrees to radians. Can you tell me where the degrees has to go? It's got to go in the bottom to cancel out. And what's the number with degrees? 180. What's my other number? Pi. And now here I will reduce top and bottom by the biggest number that I can. Anybody think they see the biggest number that goes into 150 and 180?
30.
Yep, Shakira, the 30. 30 goes into 150 5 times. 30 goes into 180 6 times. So what's my final answer? Yes, Selenia.
5 pi over 6.
5 pi over 6. Now, do I need to put RAD on it? No. Okay, because it's an angle, we just got to get used to the fact if there's no little circle, it's automatically radians. Okay? Take a second, try that one on your own. See if you can convert negative 45 degrees to radians. Okay, as a hint, if an angle is negative when it's in degrees, it's still negative when it's in radians. Just pretend like it's positive 45 and then put a negative on the front when you're done. Okay, it's still going to be negative. All right, so same kind of problem as last time. 180 degrees has to go in the bottom, so degrees cancels out. Pi goes in the top. And what can you reduce 45 and 180 by? 45 is the biggest number. Goes in once. How many times, Kyle, does that go into 180? 4 times. So you should get negative 1 pi. Or you can just put negative pi over 4. If you had negative 1/4 pi, well, it's really the same thing. Okay, any questions on that? I'm going to skip over that one. I'll give you the answer. It's pi over 2. So if you want to practice one before the test or something, that might be a good one to try. Let's do this one, and I'm going to change the directions. I'm going to say round to 2 decimal places. Okay. The reason I'm asking you to round it is because 107 is not a multiple of 30. It's not a multiple of 45. That's when they usually use a decimal. Okay, I still do it exactly the same way. Bless you. Degrees in the bottom, pi in the top. The only difference is now I'm actually going to do that out, okay, on my calculator. All right, so I've got, what is it, 107 times pi divided by 180. Okay, and the way I'd like you to type in pi is to use the pi button. Okay, I'll show you on the next problem, if you don't, what happens with the accuracy. Okay, so there's 107 times pi divided by 180, so that's about 1.87 radians. Do I need RAD? No. Okay, so any questions on changing degrees to radians? Okay, last thing we'll look at is how we change it the other way from radians back to degrees. Okay, I'll put RAD on the first one, but we got to get used to not seeing it after this. All right, so this time it's pi over 6 radians. Okay, radians is in the top. My goal is to get degrees. So I want radians to disappear. Where does radians have to go to disappear? It's got to go where? In the denominator. Yep. And what's the number that we always think of when we think radians? Not 180, that's for degrees. Pi. Remember, the number with radians, we always think pi. Degrees, think 180. Those are your only 2 choices, pi and 180. That's it. So degrees goes in the top, and what's that number? There's my 180. And what cancels out here before I multiply? Yep, the pi's cancel out. Does anything else completely just cancel out? I can also reduce, and I'm going to do that too.
The radians.
But I can, yep, completely cancel out radians. And I'm left with 180 divided by 6. Okay, how many times does 6 go into 180? 30. So the only thing I'm left with is 30 degrees divided by 1. So just 30 degrees. Any questions on that one? All right. Let's try 3 pi over 2, and that's how you'd see it written in your book. Okay, Marquise, what am I going to multiply by here?
180
Good, where's that going to go?
on the top.
Nice. 180 in the top. And what else?
Divide by 5.
Perfect. Pi in the bottom. Marquise, do I need to put the little circle on the 180?
Yeah.
Absolutely. Anytime you have something in degrees, you have to put the circle. Okay, and Rebecca, what can I cancel out here? Yep. Pi's are gone. 2 goes into 180 how many times? 90. So I'm left with 3 times 90, which is how much? 270. Okay, so a lot of times when you change from radians to degrees, if you had pi in the original, it cancels out and you get a very nice answer. Okay, any question on how you do this one? It's pretty much the same thing, okay? I know in my head that pi over 4 is 45 degrees. Well, this is triple 45 degrees. That's how I would do that one in my head quickly. Just because I memorized pi over 4 is 45, it's triple 45, which is 135, with a negative info. So it helps if you can memorize that pi over 4 is 45, pi over 6 is 30, and pi over 3 is 60. If you memorize those 3, it makes it a little faster, and you don't necessarily have to go through all these steps every time. But to start out with, you can definitely do all these steps if you need to. Right. So last one we'll look at, kind of like the last one we did when we converted the other way. Let's round it to 2 decimal places. All right, so I have an invisible RAD in the top here. So where does that mean radians is going to go in this fraction? It's going to go in the bottom, and the number with radians? Pi. Number with degrees? 180. And because it's asking me to round it, I'm just going to use my calculator. Type it in. Okay, so I have 3 times 180 divided by pi. So that's going to be 540. Press divided by pi. Oops. And I get about 171 point, where does that round to? 0.89, yes. Always make sure you round properly.
How off would it be if you say 3.14?
Yeah, let's take a look at that. So if we use 3.14, okay, we're going to get 540 divided by 3.14. You get 171.97. Okay, that's quite a bit different. 89 versus 97. The decimal's off a lot. So make sure you use the pi button. Any questions on that? All right, so most important thing we learned today is how we can change between degrees and radians. Okay, and that'll be at least 5 or 6 problems of what's on the test. Okay, the homework is page 99. 36 to 68 even. So we'll look at that first thing tomorrow, and then we will finish up section 2.1, and we'll have our first test on Friday. Okay, I will be after school today for extra help a little bit, because tomorrow is back to school night, so I won't be able to stay tomorrow. Okay, so I'll be after school today.